Alright, in this video we are going to take a look at Algebra Revision Sheet 4. So this involved a variety of different topics, and we're starting with our simultaneous equation with three variables. So we've got three equations and three unknowns, so it is solvable. So what I need to do is combine the right set of equations to figure out what x, y and z is. So what I would do first, the easiest one to target in this instance is the y. So if I take the red equation here, and I also take the yellow equation here, with very little changes, or in fact no changes at all, I can get to a stage where I can eliminate my y values. If I just add those two lines together now, those two equations, I'm going to get x plus 2x is going to give me 3x's. Plus y minus y, that becomes 0. And then I have plus z plus 3z, which is going to give me 4z's. And that's all going to be equal to 5 plus 3, which is 8. So there's my first equation that I'm interested in. I now need to find a second equation in x and z. So I'm going to use two other equations. So let's pick the yellow and the blue in this scenario. So bring those back. I'm going to copy them and paste them here. So picking the yellow and the blue this time, I do actually have to make some changes for this to work, to be able to eliminate the y's. So what I could do here is multiply the yellow equation by 2. And if I multiply everything in the yellow equation by 2, what I will get then is I'm going to have 2x becomes 4x. So 4x minus y by 2 becomes minus 2y plus 6z is equal to 6. And then of course I haven't changed anything at all about the blue equation. What we will see now is that it's actually aligned perfectly in the perfect position to be able to eliminate our y's. So if I add the two lines together now, so I'm going to change the color, I'm going to do 4x plus 3x. Adding those two lines together, I get 7x. Minus 2y plus 2y, that's going to become 0. Then I've got 6z minus 5z, so I'm going to have 6z minus 5z is plus 1z is equal to 27. So 6 plus 21, 27. I now have two equations in two unknowns. I can solve for x and z now with this information. So I'm going to take the two equations that I have. 3x plus 4z is equal to 8. And I'm going to take the other equation, which was 7x plus z is equal to 27. Now, the easiest thing to do here to start solving this would be to change the bottom equation by multiplying that by minus 4. And we'll see why I say minus 4 in a moment. If I multiply this out, I'm going to get 3x. There's no change to the top one. So 3x plus 4z is equal to 8. Multiplying the bottom one out by minus 4 gives me minus 28x minus 4z, and checking then what 27 by minus 4 is going to give us, it gives us minus 108. If I add those two lines together now, what I get is I'm going to have 3x plus 4z is equal to 8, minus 28x minus 4z is equal to 108, minus 108. Doing that, I'm going to get minus 25x is equal to minus 100. Divide both sides by minus 25, and I'm going to be left with x is equal to 4. So a nice tidy answer at the end of all of that. So x was equal to 4. Now that I have a value for x, I can take one of my equations here and substitute back in to figure out what z was. So this was a general equation for any value of x there. I now know I'm specifically talking about the value of x where they're meeting, which is 4. So I've got this scenario, and I'm going to put in my 4 here. And then I'm going to get 3 by 4 is 12 plus 4z is equal to 8. Subtract 12 from both sides, and I get 4z is equal to minus 4. So z is equal to minus 1. there's another piece of information that I have. And now that I have two of those unknowns, I can now find the third and final unknown, which we actually eliminated right way back at the beginning. So I'm just going to pick one of these equations. So if I pick x plus y plus z is equal to 5 here, and I'm going to substitute in, so I'm going to use this space over here to do that. Instead of the values that I was using before, x and z, I'm going to be able to replace x, for example, with the number 4. So I'm going to have 4 plus y, which I don't know, and that's okay, plus y, plus, and then instead of z, I'm going to write in minus 1, is equal to 5. Tidying all that out then, I've got y, and if I tidy up 4, take away 1, what I'm going to have is plus 3, and then that's going to equal to 5. So then I have y plus 3 is equal to 5, so y must be equal to 2. So there's the three values for x, y, and z when those three equations meet. Right, so for question 2, it was a question that not many people did to completion correctly. So let's take a look at what we could do here. The very first step I could do for my any correct step would be to change this divide to multiply and multiply by the reciprocal. So what I could say here is that I have x plus 3 all over y minus x. That doesn't change, but we multiply by the reciprocal of the other fraction. So I'm going to multiply by the second fraction flipped around, plus 3x like so. That's the very first thing I could do. Now what I would do is start to factorize and break it down into the simplest form. So x plus 3, there is no common factor. Well, 1 is a common factor, but it's not something worth taking out. The same with y minus x. Now, on top though, there is no common factor, but it is something familiar. It is the difference of two squares, right? So we have to think, is there a common factor? Is it a quadratic? Is it a rule that we're familiar with? And this one is a rule. It's a square number, take away another square number. So it's the difference of two squares. Then on the bottom, do they have a common factor? Yes. What's the highest common factor? Well, x goes into both of them. So I'm going to be left with x plus 3. And now what I can see is that I am multiplying in by x plus 3 on the top, and I am then going to be multiplying by x plus 3 on the bottom. If a number is on the bottom, it is dividing. If a number is on the top, it's multiplying. So if I'm multiplying and dividing by the same thing, it becomes 1. So what I really get out of this is I get, let's write it over here, we're going to have 1. So that's why I've not just said cancel here, I've said it goes to 1. 1 all over y minus x. And then we're going to be multiplying by x minus y, x plus y, all over x. Now, at this point here, I am going to take note of the fact that this is very similar to this one here. So y minus x and x minus y. If I could change the signs of this somehow, I could potentially get those two eliminated to become 1. And in fact, I can get them to change signs. If I multiply the top and the bottom of this fraction by minus 1, so multiply everything by minus 1, I get minus y plus x times x minus y, x plus y, all over x. What I can do with that then is rearrange it so that I get minus 1 all over, and then I can change that to x plus y times x minus y, sorry, that should be a minus here, x minus y. That can be x minus y here, and then we're going to have multiply that by x minus y, x plus y, all over x. And what will happen now is, because I've multiplied in on the top and the bottom by the same thing, they become 1. So really what I'm left with here is minus 1. If I move it over here, what I'm left with is minus 1 by x plus y all over x, because that becomes 1, remember? So x by 1 is x, which could be, we could leave it as it is, or we could multiply it out, whichever, and we're going to get this scenario. So we've got all over x. So for question 3, similar to question 1, we need to break it down into small manageable pieces for ourselves and say, what do I know about this sort of a question? So that is a quadratic, and being able to name it allows me to start strategizing. So make sure you can label them in your mind. Is it linear? Is it quadratic? Is it exponential? Is it the difference of 2 cubes, difference of 2 squares, whatever it is. So this is going to be a quadratic. And I'm going to see what could I factorize that into. So the factors of 8x and the factors of 9 to make 34. So if I go with, for example, 4 and 2, 9, so that's 4x and 2x, 9 and 1. And I'm going to put minus here and plus here. So I'm factorizing this quadratic. So that becomes minus 36x plus 2x. That will give me minus 34x. So those are my factors here. So that wasn't so bad. Then I've got 4x plus 1 multiplied on the bottom. And then I'm going to have multiplied by 3x. And then this one on the bottom here, that could actually be written as 2x all squared minus 9 squared. So that step was really important. That's a square number, and both of those pieces are a square, so I can write it like so. That then allows me to, if I keep everything else the same, what I could do with that square number on the bottom, those square numbers, is do the difference of 2 squares, because I have a square number take away another square number. So I know that that factorizes down to give me 2x minus 9, 2x plus 9. And then what I know, similar to question 2, is that if I multiply in on the top by 4x plus 1 and I multiply it in on the bottom, that is going to become 1. So we've got 1. And same thing over here, 2x minus 9 multiplied by 3x, but then I'm going to be multiplying it in on the bottom, so it's going to become 1. So those simplify down to give me 1. So what I really have here then is I have 3x all over 2x plus 9. That's what that simplifies down to be. For question 4 here, we're looking at indices. And what we know about indices is we can't really work with them unless they're in the same base. So what I must do is make sure that they are all in the same base. What do I mean by that? Well, 16 could actually be written as 2 to the power of 4. And in fact, root 8, that's the same thing as 2 root 2, which also could be written as 2 to the power of 3 over 2. Right, so I could write that as 2 to the power of 3 over 2. So that's what I have. All I've done there is I've replaced the 16 with 2 to the power of 4. So let's color coordinate them so we can see what I've done. So I have 16 is 2 to the power of 4, and root 8 is, 8 is 2 cubed, and I have it square rooted. So I've just done, basically, let me go slower on that over here as a side note. 8 is going to be 2 cubed. So what I have is the square root of 2 cubed. And what I know about a square root is that there's actually a small little 2 in there that we don't talk about, because the square root is that symbol. We don't need to put the 2 in there. That's what the symbol means. It means the second root. And I know then, using indice rules, that I could reverse that to give me a fraction as 2 to the 3 all over 2. And so what I do then is I'm going to use the indice rule. That is, if I have a fraction and I raise it to a power, then both the top and the bottom get raised to that power. So what I'm going to get here then is I'm going to get 2 to the power of, that's going to be 2 to the power of 12, and then I'm going to have 2 to the power of 9 over 2. So 2 to the power of 9 over 2, and that's going to be equal to 2 to the 2x minus 1. Now what I know about this sort of setup is that when I have divide in indices, if I have a to the p all over a to the q, I know that what happens is I subtract the powers. So long as they have the same base, I can subtract the powers. And what I have there then, so I'm going to have 2 to the power of 12 minus 9 over 2. So could I simplify that? I'm going to have 12 minus 9 over 2 actually simplifies down to be 15 over 2. So what I have then is 2 to the 2x minus 1 is equal to 15 over 2. I know that both of the bases are the same, so I can focus on the powers. So I'm just going to focus on this part. Now we can use logs to get out of it. You can take log to the base 2 of both sides and we'll still end up in the same position. But I know that they are the same base, so I can ignore them. So I'm going to have 2 to the power of x minus 1 must be the same thing as 15 over 2 because they're telling us it's equivalent. And the only thing that's different is the 2 to the x minus 1 and power of 15 over 2. So tidying that out then, multiply everything through by 2 and I'm going to get 4x minus 2 is equal to 15. I'm just going to slide this up a little bit so that we have more space to work with this question. And I've got 4x minus 2 is equal to 15. So I can then add 2 rather to both sides. So I'm going to get 4x is equal to 17. So x is equal to 17 over 4. Not the nicest of numbers, but there we have it. X is 17 over 4. So for the final question that we had, we are given an equation that is 3 to the power of x minus 3 to the power of 1 minus x plus 2 is equal to 0. Well, we know that we don't deal with equations where we have the variable or the thing that we're looking for in the power. So I'm going to change that by replacing every time that I have 3 to the x, and I'm going to replace that with y. So that one's straightforward. The very first one, 3 to the x, I can replace that with y. But we're going to run into a slight problem here when we have 3 to the power of 1 minus x. That's going to need a little bit of work. So I'm going to write it out over here to see can I simplify it or change it in any way. What I can see about it is that I have 3 to the 1 minus x, and the only way that I could have gotten a minus in the indices is if I had divide, and they must have the same base, so they must both be of the same base for this to have worked out. So they must both have 3 to the power of 1 all over 3 to the x. And what did we say about 3 to the x? Well, we know 3 to the x is actually being replaced by y now. So that's going to be filled in for here. So what I actually have in this equation then is y, and then I'm going to have my minus 3 to the 1 minus x is now being replaced by 3 all over y. So I'm going to replace that there. Plus 2 is equal to 0. So here's my workings. I'm just going to push them slightly further over so that we've got some more workspace here. So what I would do here then is I would tidy that out. So I don't want to deal with a fraction, so I'm going to get rid of it by multiplying everything through by y. So I'm going to get y squared minus 3 to the power of 1, and that's going to be 3. Because when I have 3 to the power of 1 divided by y multiplied by y, the y multiplied by and divided y becomes 1. And then we're going to have plus 2 multiplied by y. And all of that equals 0. And what we actually have now is a really nice question that we would have gotten way back in junior cycle maths or junior cert maths, which is a factorization question for a quadratic. So I'm just going to change everything to black now to keep it simple and not waste any time. So we know where everything came from at this stage. We just need to factorize this out. So if I factorize that, then I'm going to get y and y. I'm going to get 3 and 1, and I'm going to go plus and minus, and that equals 0. At this stage I have two things that are multiplied together, and that gives me 0. So what does that tell me? It tells me that either y minus 1 is equal to 0, or that y plus 3 is equal to 0. And from this, I can see that y is equal to 1 or y is equal to minus 3. So that's what we have. Now, we were not asked ever to find the value for y. We were asked to find the value for x. So we need to be careful with that and make sure that we find our connection between our x and y. We were the ones who proposed that connection. The connection is that 3 to the x is equal to y. So I'm now going to work with these values. Now 3 to the x is equal to y and y is equal to 1. So I'm going to replace my y here with 1, and here 3 to the x is equal to y. So our y in this scenario was equal to minus 3. At this point, what we could use is logarithms. So you can take log to the base 3 of both sides. So I will do it on this side just to show what happens. So if I take log to the base 3 of 3x, 3 to the x, and I do the exact same thing to the other side, what happens is we get an error. We can't have a negative log, so it can't equal minus 3. So that one is eliminated straight away. This one, another way you could solve it is by thinking about what would I have to put 3 to the power of to get 1? And the answer is that if you put any number to the power of 0, you get 1. So what I can see from this is that 3 must be to the power of 0, so x must be equal to 0.